multiple projects. In this video, we are going to explain about the project, which is comparative study of optimum medical diagnosis of human heart disease using machine learning technique with and without sequential feature selection. Heart disease stands as a formidable global health challenge. Being the leading cause of death in many countries, accurate and timely diagnosis of heart disease is paramount in healthcare. However, this process is riddled with challenges. Traditional diagnostic methods may not always provide the precision required, leading to delayed treatment and potential life-threatening consequences. Addressing the healthcare. In today's healthcare, advanced tools and machine learning offer potential for more accurate, timely diagnosis. We are leveraging machine learning to build a robust heart disease diagnostic system to reduce high mortality rates through early detection. The growing healthcare data provides a unique opportunity for data-driven decision making, ultimately improving patient care and outcomes. Catalyzing transformative change in healthcare. This project revolutionizes heart disease diagnosis by harnessing the power of machine learning and data-driven insights. We anticipate a profound impact on patient care, foreseeing reduced mortality rates, enhanced accuracy in diagnosis. The primary aim is to improve heart disease diagnosis by utilizing a range of machine learning algorithms such as SVM, random forest, decision tree, MLP with ANN, SMO, linear SVC, gradient boosting classifier, LDA, KNN, XGBoost, and a voting classifier. We are developing a comprehensive diagnostic system that combines these algorithms to analyze patient data effectively. The system aims to consider various factors and symptoms, enhancing diagnostic accuracy. Through the multi-algorithmic approach, we aim to achieve earlier detection of heart disease, leading to reduced mortality rates and ultimately revolutionizing heart disease diagnosis for more effective patient care. For implementing the project, we need few requirements, and they are hardware requirements. In hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. For implementing the project, we have designed few modules in the flow of work, and they are: first one is importing the packages. In this module, various Python libraries and packages are imported, and they are NumPy. It is imported to handle numerical operations efficiently. Pandas is imported for data manipulation and analysis. Matplotlib and Seaborn for visualization. Scikit-learn for machine learning, and TensorFlow for deep learning. Exploring the dataset. In this step, the heart disease UCI dataset is examined to understand its structure, content, and potential features for machine learning. Data processing using Pandas data frame. This module involves data cleaning, handling missing values, and structuring the dataset using Pandas data frame to make it suitable for analysis and model building. Visualization using Seaborn and Matplotlib. Here, the data is visualized using Seaborn and Matplotlib to gain insights, understanding patterns, and exploring relationship between variables. Feature selection. This step includes feature selection techniques such as recursive feature elimination, which is RFE with linear regression, sequential feature selector, which is SFS with KNN, and also a scenario without feature selection to determine which features are most relevant for the models. Building the model. This module involves creating machine learning models for heart disease prediction. Multiple algorithms are: the first one is SVM, which is support vector machine. It is a supervised machine learning algorithm that classifies data by finding an optimal hyperplane that maximizes the margin between different classes. It is used because it's effective for binary classification tasks like heart disease prediction. It seeks to find best separation between individual with and without heart disease based on their feature data. Random forest. It is an ensemble learning algorithm that combines multiple decision trees to make predictions. Each tree in the forest independently predicts the outcome, and the final prediction is based on majority vote or averaging. It is employed due to its ability to handle complex relationships in the data and reduce overfitting. It helps to improve the accuracy and robustness of heart disease prediction models. Decision tree J48. Decision tree is like a tree-like structure where internal nodes represent features, branches represent decisions, and leaf nodes represent outcomes. J48 is an extension version of the decision tree algorithm. It is interpretable and easy to understand. J48 is used for the transparency in decision making during heart disease prediction. It helps identifying key features leading to prediction outcome. MLP with ANN, which is Multiple Layer Perceptron Artificial Neural Network. It is a deep learning algorithm consisting of multiple layers of interconnected neurons. It is capable of complex pattern recognition and learning from the data. It is employed for its ability to capture intricate relationships within the data. It is suitable for detecting nonlinear patterns in heart disease prediction, enhancing model accuracy. SMO, which is Sequential Minimal Optimization with Linear SVC. SMO is a support vector machine algorithm used for solving quadratic optimization problems. Linear SVC is a linear version of the SVM algorithm. SMO with linear SVC is employed for its efficiency in solving linear classification problems. It is utilized in scenarios where linear separation of the data is sufficient for heart disease prediction. Coming to gradient boosting classifier, it is an ensemble learning technique that builds a series of weak learners sequentially, with each learner correcting the errors of the previous ones. Gradient boosting is used to improve prediction accuracy by iteratively refining the model. It's effective in addressing bias and reducing prediction errors in heart disease diagnosis. Coming to LDA, which is Linear Discriminant Analysis, it is a dimensionality reduction and classification technique that aims to maximize the separation between different classes while minimizing the variance within each class. It is used for its dimensionality reduction and improved classification in heart disease prediction. It helps in identifying features that discriminate between patients with and without the heart disease. Coming to KNN, which is K nearest neighbor. It is a simple instance-based machine learning algorithm that classifies data points based on the majority class of the K nearest neighbors. It is employed for its simplicity and effectiveness in handling classification tasks. It is used to determine the heart disease risk based on the similarity to neighboring data points. Coming to XGBoost, it is an optimized gradient boosting algorithm designed for efficiency and performance. It's an ensemble technique that combines weak learners into a strong learner. It is used to enhance prediction accuracy and speed. It is especially useful for handling large data sets and optimizing model performance in heart disease diagnosis. Coming to voting classifier, using SVM, decision tree and random forest. A voting classifier combines multiple decision models, multiple learning models such as SVM, decision trees and random forest, and aggregates their prediction through voting or averaging. It combines the strengths of different algorithms to improve overall prediction accuracy. It is employed to leverage the diverse capabilities of these models in heart disease prediction. Training the model. Here the machine learning models are trained using the pre-processed dataset to learn patterns and relationships between the input features and heart disease outcomes. Flask framework with SQLite for sign-up and sign-in. This module integrates the Flask web framework with an SQLite database to provide user authentication and registration functionalities. Coming to user gives input as a feature values. In this stage, user provides their input feature values, which are inputs used for the heart disease prediction. Coming to the given input is pre-processed for prediction. In this step, the user input is pre-processed to align it with the format used during the model training. Trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model to predict the likelihood of the heart disease. Final outcome is displayed through frontend. The prediction outcome indicating the presence of risk of heart disease is displayed through the user interface, which is displayed in the frontend interface. For execution of the project, we need to open the code folder of the project, which contains the source code files. This is a static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which contains the algorithm information, and this will be loaded into the project code during runtime. And this is the IPYNB file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular for data science. This is the sign up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. Now we'll copy this and then open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command is used to change the current directory to the code folder's path. So here the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile the app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or the logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost. This one is the localhost and this is the port number, unless configured differently. Now we need to copy this local link and paste it in any browser. I prefer Google Chrome, so I will paste it in that. Here I need to paste the link and then click on enter. This is the homepage of the project, which is displayed in the browser. And this front end is built by using the Flask framework. Now we need to click on sign up. Here we need to fill all the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are my username and the password, and click on login. So this has redirected to the homepage of the project. And here we need to fill all the medical parameters of the patient and then click on submit. By that we will get the prediction whether the person has the heart disease or not. Now we will enter all the parameters step by step detailedly. So here we will enter the age of the person, which is 52. And here gender of the person, which is 1, which means he is male. And the CP value is 0 and the stress BPS is 125 and the cholesterol value is 212 and the FBS is 0 and the rest ECG is 1 and the Talach is 168 and this one as 0 and the old peak value as 1, slope as 2, CA value also as 2 and the Thal as 3. Now we will click on submit. So for the given input, it is predicted that the patient is predicted with no heart disease, which means he has no heart disease. Now we will give the other parameters of the patient. Here we will give medical parameters of the other patient and then check what will be predicted. Age of the person, gender of the person is 0, which means she is female, and the CP as 0 and the rest BPS is 100 and the cholesterol is 248, FBS is 0, rest ECG also 0 and this one as 122 and this one as 0, old peak value as 1 and the slope value as 1 and CA value as 0 and the Thal value as 2. Now we will click on predict. So it is predicted that based on the input, the patient is predicted with the heart disease. In this way, we can give medical parameters of the patient and then by clicking on submit button, we can get the predictions whether the person has disease or not, which means he has heart disease or not. Now we will sign out of the web page. Leveraging a combination of diverse range of machine learning algorithms are successfully demonstrated, including SVM, random forest, decision tree, MLP with ANN, SMO with linear SVC, gradient boosting classifier, linear discriminant classifier, KNN, XGBoost and a voting classifier. Significantly enhances the accuracy of heart disease diagnosis. This multi-algorithmic approach improves the ability to detect heart disease at any early stage. The results of the project suggest that by harnessing the power of these algorithms, healthcare professionals can potentially identify heart disease in early stages, facilitating timely intervention and treatment. This has the potential to reduce mortality rates and improve patient outcomes. This project highlights the importance of data-driven decision-making in healthcare by utilizing machine learning and feature selection techniques like sequential feature selection. The project paves the way for a new era of more precise, effective, and efficient medical diagnostics. These findings emphasize the transformative potential of advanced technology in improving patient care and healthcare outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.